Right now we're going to work on an important technique that is used often for finding zeros of polynomials or factoring. And that's of course the process of long division using polynomials. So the big idea is that you have one polynomial and you are dividing it by another one. And through the process of long division you'll be able to figure out what other smaller polynomials or even what remainder is left over. Now, it can look like a complicated process, but one thing you want to keep in mind is that it basically mirrors the process of long division with just normal numbers. So watch for those good parallels as we go through some examples. The very first thing that you want to do when doing long division with polynomials is make sure you have the correct setup. So in my problem that I had on the first board, I have the polynomial 5x cubed minus 6x squared minus 28x minus 2, and all of that is being divided by x plus 2. So you'll notice I've set it up into a normal division bar. So this first polynomial is what I'm dividing, so it goes underneath the bar, and I'm dividing it by the x plus 2, so it goes on the outside. Now what we're going to do is basically take a look at the very first two terms of each of these polynomials. I want to think to myself, what do I have to multiply x by in order to get a 5x cubed? Now if you think about that for a moment, you'll see that you would have to multiply x by a 5x squared. Let's write that on top, 5x squared. Now that will be essentially the first term of my new polynomial. So let's double check this. 5x squared times x indeed does give us a 5x cubed. I'm going to write that right underneath this one. Now we also want to take this and multiply it by the next term, so multiply by the 2. So 5x squared multiplied by 2 plus 10x squared. So just like a normal long division problem, you figure out how many times it goes in there, you write it on top, then you multiply through, write it underneath, and of course now the most important step, you want to subtract that away. I always like to put a big set of parentheses and a negative sign when I'm subtracting so I can keep track of all of my signs. Let's see how this works. So I have 5x cubed minus 5x cubed. That'll be a 0. If you do this process correctly, these first terms will always drop away, always should give you 0. If it doesn't, double check this term that you've picked the right one. Right, on to the next term. A negative 6x squared minus a 10x squared. So negative 10 minus 6, looks like I'm at a minus 16x squared. Again, the reason why I'm putting on these parentheses is so you can subtract away all of the terms. You don't want to miss any signs in there. Alright, so it looks like we have a minus 16x squared, and we want to continue doing this division process, so I'll bring down the next term, and we'll repeat this one more time. So again, I want to look at my first two terms and figure out, what would I have to multiply x by in order to get a negative 16x squared? So I'd have to multiply by a negative 16x. Now we'll take this and multiply through by both of the terms. So negative 16x times x, negative 16x squared, negative 16x times 2, a negative 32x. Alright, looking good. Of course now, let's subtract that away. Be very careful with your signs, but notice how it does work out pretty good for our first terms. So a negative 16x squared minus a minus 16x squared, that's essentially like adding a 16x squared. They'll cancel each other out and give me a 0. Negative 28x minus a minus 32x. So negative 28x plus a 32. 4x. Awesome. So we've done our subtraction. We'll bring down our next term, and of course repeat this. So what do I have to multiply x by in order to get a 4x? Well, I'll have to multiply by 4. So 4 times x, 4x, 4 times a 2, I'll get an 8. And then of course we want to subtract this away. Alright, so 4x minus 4x, gone like it should be. A negative 2 minus an 8 give me a negative 10. So since this is now lower in power than what I'm dividing it by, so it's only like x to the 0, this is considered my remainder. So what we have found is that when we take our original polynomial and we divide by x plus 2, we get the answer 5x squared minus 16x plus 4 with a remainder of negative 10. Now there's a few things you want to remember when doing the long division process that will help you out for some polynomials. Let's see those examples. One of the biggest things that you want to remember is that you should always put in placeholders for missing powers of x. So this problem looks like a fairly small one. I'm taking an x cubed minus 1 divided by an x minus 1, and it doesn't look like a whole lot's involved. But as I go to set this up, watch how many placeholders I have to put in here. So this is what's being divided, x cubed, and I have to put in all of those missing powers of x. So since I don't have an x squared, I'll put in a 0x squared. Since I don't have an x, I'll put in a 0x minus 1. Now you may be wondering, wait a minute, doesn't that mess up the problem? But when we're multiplying by 0 here, essentially that term is 0 and it's not really there anyway. We're just keeping them in there as a placeholder. Alright, dividing by x minus 1. So if you're missing any powers of x, make sure you put in those placeholders for the missing powers. Alright, now let's continue through the problem. What do I have to multiply x by in order to get an x cubed? How about an x squared? Multiply through, get an x cubed, multiply by the next term, minus x squared. Once you have your terms, go ahead and subtract those away. First two terms are canceling each other out. Awesome. 0 minus a minus x, so 0 plus an x squared, x squared. Bring down the next term. Continue again. X times what would give me an x squared? Well, I think x is the thing that will do it. So x times x, x squared. X times a minus 1, minus 1x. And of course we want to subtract that away. So x squared minus x squared is gone. 0 minus a minus 1, it's like plus 1. So 1x. And we'll bring down our minus 1. Alright, looks good. Do this one more time. X times what would give me a 1x? A 1. So 1 times x, 1x. 1 times a negative 1, negative 1. And now we subtract it away. And since these are exactly the same, it looks like we'll just get 0. In other words, we have no remainder, and it looks like it went in evenly. Awesome. So remember that when doing the long division process, it looks a lot like normal division with numbers. Make sure that you write your polynomial that is being divided in descending order, and you put in any placeholders for those missing powers of x. If you'd like to see some more videos, please visit mysecretmathtutor.com.